If you've ever battled a slow Odoo instance, you know the feeling. The frustration is real. Well, in this explainer, we're going to tear down a real-world case study on how to take a crawling Odoo system on AWS and make it absolutely fly. Let's get right into it. So, what was the big ugly problem? It was this: 8 seconds. A full 8 seconds just to load one simple sales order. Now imagine a business with 150 people trying to work like that. It's not just annoying, it's a complete productivity killer. And man, this quote just says it all, doesn't it? You've got angry users, you've got your boss breathing down your neck, and you're looking at a pretty decent system. We're talking 4 cores, 16 gigs of RAM, and it's just redlining all day long. It feels like you're just burning money on hardware for no good reason. Which leads to the big question, right? If the machine itself wasn't the bottleneck, then what on earth was? And the answer, believe it or not, was hiding in plain sight. It was the default Postgres database settings, which are basically tuned for a tiny hobby blog, not a hardworking ERP system. And this brings us to the good stuff. Now, PostgreSQL has literally hundreds of settings you could tweak, but we're going to focus on what we'll call the Magic 6. These are the parameters that give you the biggest bang for your buck and the most dramatic performance gains for Odoo. First step is shared buffers. The easiest way to think about this is like the database's main workbench. It's the chunk of RAM it sets aside to keep all its most used tools and data right there, ready to grab in an instant. And just look at this difference. The default is a tiny, almost laughable 128 megabytes. The fix? Bumping that all the way up to 4 gigabytes, a full 25% of the system's RAM. Seriously, this one change alone is an absolute game changer. And here's the proof in the pudding. Just by getting shared buffers rate, the most common queries instantly got 40% faster. That is a huge, immediate win from just changing one little number. Okay, next up, effective cache size. Now this one's a little different, and it's super interesting. This setting doesn't actually use any memory. It's more like a friendly hint you give to the database's brain, the query planner. You're basically saying, hey, just so you know, you've got about this much total memory to play with for caching, so plan your work smarter. So the team set this to 12 gigs, which is about 75% of the total RAM. Again, this doesn't make any single query magically faster, but over thousands and thousands of operations, it helps PostgreSQL make consistently better decisions. And that adds up to a way more efficient system overall. Now, let's talk about these two together, WorkMem and Max Connections, because you really can't think about one without the other. WorkMem is the little slice of memory each database operation gets for things like sorting data. Bumping it to 32 megs is great because it stops the database from having to write temporary files to the slow disk. But, and this is a big but, if you have too many connections all asking for that memory at once, you'll run out. That's why they lowered Max Connections to 100. It's a classic balancing act. Then you've got Maintenance Work Mem. This is a special, dedicated pool of memory that's only used for housekeeping jobs. You know, things like cleaning up old dead data, a process called vacuuming, or building new indexes so your searches are faster. Now, this won't change what your users feel day to day, but wow, look at the impact on maintenance. By giving it a full gigabyte to work with, that weekly vacuuming job went from taking a painful 45 minutes all the way down to just 12. That means you get a healthier, cleaner database in a fraction of the time. All right, so we've tuned the database and it's running like a dream. But we're only halfway there, because if your Odoo application server isn't configured to talk to the database properly, you're just going to waste all those shiny new resources we just optimized. And the place to start is this beautifully simple formula for your Odoo workers. You just take the number of CPU cores you have, multiply it by 2, and add 1. So for their 4-core instance, that meant 9 workers was the sweet spot to handle all the user requests without bogging the system down. But you can't just unleash those workers. You have to put some guardrails on them. Setting a soft memory limit of 2 gigs tells a worker, hey, finish what you're doing, then please restart. A hard limit of 2.5 gigs is much meaner. It just kills the process right then and there. This is absolutely crucial to prevent one single bad process from eating up all your memory and crashing the entire server. Okay, let's talk about the foundation, because all the tuning in the world isn't going to stick if you don't have the right maintenance routines and, just as important, the right hardware underneath it all to support it for the long haul. And would you look at that? It's the classic 80-20 rule in action. Using a tool called AWS Performance Insights, they found that just 3 specific slow-running queries
were eating up a staggering 80% of the total database time. Fixing just those 3 queries had a massive, outsized impact on everything. So this all boils down to a super critical maintenance checklist. You gotta be proactive. Use tools to hunt down your slow queries. Then, for tables that change a lot, like the mail message table in Odoo, you need to vacuum them more aggressively. Add indexes where people are searching a lot. And yeah, that last point, using SSDs for storage, that is 100% non-negotiable for any modern ERP.
Okay, you've nailed the fundamentals. The system is stable and fast. Are you ready to level up and squeeze out every last drop of speed? Let's look at a couple of advanced techniques.
First up is PG Bouncer. Think of it as a super efficient manager for your database connections. Instead of making a new one every single time, it recycles existing ones. Just adding this improved response times across the board by 15%. Second, they moved all the user session data out of the main database and into Redis, which is a lightning-fast memory store. This took a surprising amount of load off Postgres.
Phew, that was a lot to cover. So after all of that work, what were the things that really moved the needle? Let's boil it all down into a priority list so you know exactly where to start. Here's your action plan. Number 1, without a doubt, was tuning those memory parameters, shared_buffers, and effective cache size. That was the single biggest win. Number 2, hunting down and fixing those top 3 slow queries. That literally saved them from having to buy a bigger, more expensive server. Third was connection pooling, which gave a really nice, noticeable boost to everything. And finally, number 4, automating all that maintenance. That's what stops performance from slowly creeping back down over time. And that brings us to the end. We've walked through the settings, the maintenance, and the priorities that took an Odoo system from a painful crawl to an absolute sprint. And it really just leaves one question for you to think about. When you look at your own system, what's the first bottleneck